The advances in multimodal foundation models have greatly enhanced the auto-labeling of large-scale datasets, facilitating the process to collect extensive amounts of labeled data. Incorporating foundation models in data generation pipelines has greatly enhanced various downstream tasks. For example, in the challenging vision language task, open vocabulary image segmentation, foundation models are commonly leveraged for generating vast amounts of image segment and label pairs to train OVIS models with better performance. However, existing approaches focus more on data quantity over quality, and it is challenging to validate large volumes of multimodal data without ground truth. In OVIS data issue considerations mainly include two categories. Label issues, whether the labels are ambiguous or not relevant to the corresponding image segment. Alignment issues, whether the labels are not meaningful, but somehow misaligned with the current segment. With no ground truth to refer to, the key question here is how can we effectively detect such issues, and how to solve them without excessive human efforts. To overcome these challenges, in this paper, we introduce VISTA, a novel visual analytics system to enhance the quality of foundation model-generated data with human assistance. VISTA incorporates a multi-phase data validation framework, detecting and summarizing potential data issues, and allowing human validators to identify, understand, and correct them effectively. The VISTA interface consists of 5 views. The label view displays a two-dimensional label distribution according to quality evaluation metrics, enabling brushing, hovering over, or highlighting to investigate potential label issues. The issue pattern view visualizes common alignment issues using an upset visualization. Users can rank according to different attributes, explore their patterns, and check further details by selecting a specific group. The embedding view presents the segment distributions with our summarized semantics, and the sample view shows segments images related to the current selection. These two views will be updated following the user's selection, providing complementary information to support issue verification. Users can double-click to annotate a verified issue and provide solutions, either from our provided options or create a new one. The annotation panel provides a summary of the annotated issues, allowing users to modify if needed. The Apply button at the bottom will record all annotations and apply them to enhance data quality. Now let's evaluate VISTA with a case study on Cocoa Stuff for the Open Vocabulary Image Segmentation task. We check whether VISTA can enhance the quality of data in the format of image segment and textual label pairs, and whether such VISTA-enhanced data can improve OVIS performance. After loading the data into our system, let's start by validating label issues from the label view. We notice that the predominant labels with low segment and label similarity and high frequency are located near the top left of the grid visualization. By checking a cell with many labels, we observe labels that are not meaningful nouns, such as front. By selecting this label, and checking the updated distribution and image samples, we can observe that this label front is assigned to a large amount of image segments distributed across the entire view, and is irrelevant to the actual content of the segment. Thus, we annotate it as an irrelevant label and solve it by removing the label. After checking other labels to validate their issues, let's move to the issue pattern view to explore potential alignment issues. We notice 3 groups of bars corresponding to small, middle, and large values of 3 metrics, respectively. And the large segment size bar is the highest, indicating more data are related to this feature. Therefore, we rank all groups based on the error rate and group them by the large segment size. By checking the top-ranked group, we find related segments are mainly image backgrounds, and the labels assigned to them are pretty noisy. Moreover, despite the labels for highlighted segments being wrong, their neighbors have correct labels. Thus, we annotate this issue as extremity-sized segmentation and the solution as find matching labels in neighbors. After annotating the highlighted issues following the visual guidance of VISTA, we can apply them to improve the data quality. To evaluate whether our data can improve OVIS model, we apply a training-free OVIS method and test its performance with the original foundation model-generated data. From VISTA interface, we have fixed errors. With the enhanced data, the same OVIS method achieves a significantly improved performance, indicating the effectiveness of the VISTA framework. In conclusion, VISTA is a novel visual analytics framework to enhance multimodal data quality, incorporates automated computational processes with human expertise. We have used OVIS to illustrate our strategy. but VISTA is adaptable to other multimodal tasks, such as image classification and object detection. As AI models increasingly demand high-quality data, VISTA is paving the way for the next generation of efficient data curation systems. Thanks. Please check our paper for more details.